So exponential and natural part, which should tell you that there's going to be a what? Part 2. Y'all are brilliant. Okay, and this one, spring break, I suggest you allow yourself, give it to me tomorrow. Man, I am like really needing a break. No, that would be late. I'm not taking it late like that. After whatever this break is, this Thanksgiving break on Monday, on the 26th, what it says, of this year. And so but I would suggest you try and give it to me tomorrow. All right, I'm going to get this. So if you look at this on number 1, first of all, it says graphs should be neat and accurate. You may need to plot more points than usual. We do like 3 anchor points, draw in the sketch, and if we don't hit all the points correctly, it's fine. But these you're going to want to be more accurate. So on number 1, I'm going to give you about 5 minutes, and I want you to go ahead and sketch. So go ahead and start graphing. I'm going to tell you a little few things while you're graphing. So just get the 3 things on number 1 graphed, neat and accurate. If you want to use color, you can. You don't have to, but you know some people like to do that. So, but so when I was putting this together, these grids on here, so you're pretty much going to take up the whole grid on all of these. That it's a decent size graph. Sometimes the grids are, but it'll take up kind of the whole thing. But this type of graphing that we're going to do is something that you're going to do a lot in calculus. You're going to use it, and then I went to Mr. Ackerman, and just to clarify again, because somebody asked me again the other day, so do you teach calculus? No, I do not. Mr. Ackerman teaches classes A, B, and BC, and me add these little blanks in here that we're going to fill in after graphing. The kind of things that you're going to be looking for on basic graphs like this and way more complicated graphs that you need to be able to graph accurately. And then we'll talk a little bit about what you will even do with this. We're not doing much other than graphing and shading and finding this stuff because you need the calculus to be able to do more with it, and we're just not ready for that. But go ahead and get this graphed. I'll give you a minute to finish that up in there. Go ahead and get mine graph. Oh, and by the way, I put it over there on the board. I forgot to tell you all that. Since I've said you might need to plot more points than usual. E squared is about 7.4. 7.4 is good enough to get on this grid. So when you want that point over there so that you can get the shape right, not just e to the first, but e to the second power also to have it accurate on your graph. Okay, so that means if I start with this one, 0, 1. I wish I had this undo feature in everything I drew. All right, there we go. That looks a little bit better. I want mine to at least look decent. Okay, and then this one. So, and then this one is just a transformation. That should be a pretty easy thing for you to graph accurately. Goodness. Okay. So much easier on paper. Good. All right, and then I'm going to cheat on my line because I can cheat on my line. You all have a straight edge. That's the same kind of cheating. All right. And then my e to the x does have an asymptote. Whether it's in there or not doesn't really affect anything that we're doing right now, but it is there. Okay, so I have graphed my 3 functions. Yours should look very similar to that, right? Neat and accurate. You can't just put some slop on there because some of the other ones won't turn out so nicely for you. So then it says to sketch and shade the region enclosed by these graphs. So enclosed, bless you. Enclosed would mean an enclosed region, right? Not an open region. There are 3 functions, so my enclosed region most likely has 3 sides, right? So I've got this part right here is what is enclosed by those functions, so we shade that in. So when you graph things like this, you may be interested in what the area of that section is to do whatever it is you need to do mathematically with it. Obviously, this isn't going to be an area formula that you know, like 1/2 base times height or something. No, this is where integrals come into play in the calculus that you don't know yet, and we're not getting into. I'm not even sure in calculus they've talked about integrals yet, but they will. That is definitely a big part of it. But so, that was your 5 minutes, which was too much time anyway. So we found the area. That's all we can do right now is graph it and shade it. And then in order to do what you need to do with it mathematically past that, you have to identify the upper function, the lower function, and the left and right boundary. That's very, very easy to do. When you look at this, the upper function here is the one that's on top of the shaded region. So that would be the y equals e to the x. The lower function would be what's on the bottom of my shaded region, which would be the y equals x minus 1 squared. Then I need the left and right boundaries of this. So the left boundary of the shaded region is x equals 0. The right boundary is x equals 1. Okay, and that's really all we can do right now with that. You can do all that, then when you learn the rest of it, you just go forth from there. But you can't be afraid of shading them and graphing them. The graphs have to be, you know, this is more of a graph instead of a sketch. Like a lot of what we've been doing is sketching because we can't find all this very specific points sometimes. But these are actual graphs. So the same type of thing is going to happen on 2 and on 3. But on 3, if you look at it, you're going to end up with 2 sections. And on the first section, it says the left boundary to just label the point A on the graph because you're not going to be able to find the x value. When you do and you try and solve it, you end up with an x in an exponent and not in an exponent, or then in a log and not in a log, and you can't get to it with the math that you can do. So we just literally label the point A on the graph. These other x's you can actually find. Okay? So once you graph it, if you don't have 2 sections, your graph isn't right. You need to go, like I said, you're going to use pretty much the whole graph, the whole grid on these. So on this one, you know, I could only go to x equals 2, and then it comes way up here, and this one would come off. So I've graphed everything I could. On here, you want to make sure on both of them that you go all the way out to where x equals 8. Okay, if you don't have the x value of, you know, when x is 8, what is y for both of them plotted, then you don't have enough points. You don't necessarily have to do every single, you know, 1 through 8 or whatever. You could do all the evens, something like that, but you need multiple points plotted there to make it work for you. Okay, we good? All right, now flip it over on the back. This is where the real fun happens. Okay? Now I want you to remember, and I'm not sure that I've actually said this to y'all this year, but I am never going to give you something that you're not capable of doing. I'm not going to set you up for failure. If I give you something that you aren't capable of doing 100%, I'm going to tell you, you don't know all the math you need for this, but I want you to see what you can do everything you can do. You will get stuck, and when you get stuck, that's fine. I mean, I'll be honest with you about that. There is nothing on here that you haven't seen before that you can't do. If you can't do this and it's too hard, it's because you're telling yourself you can't do it and that it's too hard. Okay? You need to look at these, think about what you know how to do mathematically, and have some confidence and do it, because it is not as crazy as you're going to think it is. So I'm going to give you a couple minutes, or a minute or so, and I want you to start by, well, first of all, this says find the roots for the given function. So I added some little instructions there. Show the factored function, which means you're going to have to factor it, and give the roots and set notation. So I'm going to give you a minute, and I want you to start factoring number 4 there. Okay? So try and get it factored, and then I will walk you through the rest of it. What are you doing? That's not factoring. All right, so I'm going to go ahead and kind of stop you right here, because most of y'all are doing what most everybody did last period, which was not even necessarily what I expected you to do. But it's one of the things that is going to, or that already probably causes you issues with some things. So, you know, sometimes I say, you got to be careful. Don't just jump in and start doing math for the sake of doing math, because, ooh, I can do this, so I'm going to do this. And so those of you that are factoring, I mean, you're factoring, but you got to think overall big picture, like, what are we trying to do here? Because most of you are factoring this and factoring this, and they both factor. And I'm not saying that's necessarily wrong. It's not like you've done so much damage you can't undo can't do it or whatever. You can even leave it like that for right now if you want to. But that's not going to get you anywhere to solve for anything. Overall, big picture, this function that you have in front of you, how many terms does that function have? 2. I highly suggest that, especially when there's a whole lot of stuff going on, that you underline what your terms are so that you can wrap your mind around what's happening. Can you factor this? Absolutely. Is that going to help you right now? Not really. Okay, so, and I know that sometimes going in, you don't know if it's going to help you or not, so you're just kind of doing what you can do to get you to the next step, and that's okay too. So I'm not trying to poo-poo on that. But what I'm saying is you got to look at it and ask yourself, what makes the most sense here? And what do you always look for first when you go to factor? Greatest common factor. So if you look at, this is 2 terms right there. This big term plus that big term. Now each of those terms have more terms inside of them, but those are 2 big terms. Is there a GCF there? Yes. What's the GCF in those 2 terms? E to the x. So I'm going to factor out e to the x. That leaves me with, and even if I had this, whatever the factored form is, if you had that, you could leave that in there. X squared, because even when these are factored, that's still just 2 big terms. You just split them up differently. Plus 2x minus 3 plus 2x plus 2. All right. So y'all agree with me on that so far? So I just factored out that GCF. Now I look at what I have in the brackets. And the parentheses that I have inside those brackets, do they really do anything? No, they were important at this step. At this step, if they disappeared, does it change anything? No. Now, if you factored it, then they're important still because you're multiplying, right? But in order for me to combine these like terms, if you had factored these 2, you're going to have to now remultiply them and basically unfactor and do what you just did so that you can then combine like terms. Like I said, if you factored it, it's not the end of the world. You're just going to have to put it right back together. So I can drop these brackets, and this leaves me with e to the x times x squared plus 4x minus 1. And I did see a couple of you had that. You went to that step first, which is really, really good. So then at this point, can I factor this? No, it doesn't factor, right? And then let me clarify this a little bit because I feel like things have gotten confusing and I got to figure out what the right words are so that it's more clear. Because I know you came to me and we're like, oh yes, we can't factor that, right? And then we forced things into being factored, and then with our factored form we had square roots and we had i's and things like that where usually you say it doesn't factor, but then we could force it down that road because you can force it down that road. So unless you're basically told fully factor it with weird square roots and i's and everything, unless you're told that specifically, we still don't want to necessarily factor that way. We're still going to talk about, can I factor this with the logical factoring that we're used to that's not crazy weird? If the answer is no, then we have to go about it a different way. You with me on that? And I'll figure out how to make that not so confusing. So no, I can't factor this anymore right now with just good old normal factoring. So this is my factored form. It says show the factored form. Boom. Okay, so once you have something factored, when you want to solve it, you have to, how many factors do I have here? 2. I have this one and I have this one right now, right? These are my 2 factors because they get multiplied together to give me that. So I have these 2 things right here. If this was like, I'm making this up, it doesn't go with this, but if I had f of x equals 2x plus 1 times x minus 3. Then when I want to go solve it, I set each one of these equal to 0, find my x's, right? So same type of thing here. I have these 2 things, right? So I set e to the x equal to 0, and I set x squared plus 4x minus 1 equal to 0. And then I solve for x in both cases. Since I can't factor this, what's my other option here? Quadratic formula. Okay, so I'll give you a minute to get this taken care of and solve for x over here. Sing the song in your head if you have to. quadratic formula. Get it done. Something you have to know and be able to use. You cannot wait for me to walk you through everything all the time. That'll get you nowhere. So that's what we should get with the quadratic formula. Yes? Okay. I would not suggest on the quadratic formula, even though it is simple, I would not suggest skipping steps because the signs are going to kill you there when you skip steps. On any of the rest of these, I would skip any steps because, again, it's not difficult, but because there's a lot of weirdness going on there, you're likely to do something odd. All right, so that got this, found my x from over here. Now I've got to take this and solve for x. What would x equal over here? It can't, right? So, and if you're, there's a couple of different ways you can figure that out if you're not sure. Do you know what the graph of e to the x, what it looks like? Yes, you do. You should, right? E to the x looks like this. It's just it's an exponential, so the parent function looks like that, right? Like, I don't even care about the actual points. It's that, right? So what does x have to equal for y to be 0? It's never going to be that, right? And if you're still not sure what, you know, the graph doesn't make any sense to you, you could take the natural log of both sides. Natural log of e to the x equals the natural log of 0. What's the natural log of e? 1. When the base, then this and the base match is 1. So this is just 1. So this is x equals the natural log of 0. Can you take a log of 0? No, you can't take a log of 0 or a negative number. So even at this point, if you weren't sure what to do with that, you still know that that can't happen. So that doesn't make any sense either. So e to the x cannot equal 0. So I don't get a root from there. Like, it's always going to be a positive number there. Okay, or at least it can't equal 0 even if there was a reflection or something. So I have my factored form. I have done what I can to solve for x, and I'm supposed to give the roots in set notation. So this is my answer here. Okay. These are going to be easier to factor than most of the factoring stuff that you have done. It just looks bad, and it's going to push you out of your comfort zone. But e's and natural logs, like, this is just a drop in the bucket compared to the weirdness that you're going to have to be able to deal with. Everything's not always going to look the same, but the steps are exactly the same. The basic algebra never changes no matter what's in there. Okay, so I use monkeys and elephants all the time, right? So this is, you know, an elephant times a monkey plus a giraffe. I'm sorry, elephant times a monkey plus a monkey times a giraffe. Well, your GCF is the monkey, so you factor it out. It doesn't matter if you know what it is and what to do with it. It factors out. Does that make sense to you? So don't let that weirdness mess you up. I would not skip steps on the back, and be very neat and careful with your graphing on the front. And this really, you should get most of it done before the end of class. Okay? But I will walk around and help you, answer your questions, do whatever you need to do. Lie to yourself, tell yourself it's due tomorrow. Okay? Are we good? All right, good deal.